Alright, so let's learn how to use variation of parameters from an example. So here we have the system of equations. First take the homogeneous equation version. So x prime is negative 5, 1, 4, negative 2x. Drop that f. Okay. Now you want to solve this system. How do you solve it? Find the eigenvalues and the eigenvectors. To save the time, I will not do that in this video. So lambda 1 is actually negative 1. Lambda 2 is 6, negative 6. Eigenvector here is 1, 4 for this one, and for this eigenvalue negative 1, 1. So then I can write the complementary solution. Okay, C1 1, 4 e to the negative t plus C2 negative 1, 1 e to the negative 6t. This is what you first want to do. Okay, all right. Now what you do is construct the fundamental matrix. Phi t is really the matrix. You take the first part, capital X1, which is 1 times e to the negative t is e to the negative t. 4 times e to the negative t is 4 e to the negative t. The second column is negative e to the negative 6t. 1 times e to the negative 6t is e to the negative 6t. So this is phi. Okay. All right. Save it. Now the next thing is write down the formula. So to find the formula for xp is phi t integral phi inverse times f integrated with respect to t. Okay. Now see, this is too complicated to do it once. How I would do is, I would start from inside. First I will find the phi inverse, then I will multiply it by f, then I will integrate, finally then I will multiply by this phi t. So that is how I do it. Do it piece by piece. So let's first find phi inverse. So phi inverse, which we practice, okay, is we switch these twos, okay, e to the negative 6t, e to the negative t, and we multiply these two by negative. So this is e to the negative 6t, this is negative 4 e to the negative t. Be very careful. Okay, now you divide this by the determinant of, right, determinant of these two. So the determinant here will be, let's find the determinant here, e to the negative t times e to the negative 6t minus, okay, minus 4 e to the negative t times negative e to the negative 6t. So what do we get? Here we get e to the negative 7t minus, okay, and minus minus plus here, okay, plus 4 e to the negative 70. So it seems to be like 5 e to the negative 70. So this is what we get. Now divide this whole matrix by 5 e to the negative 70. Okay, so let's see what we get. All right, so phi inverse is, let's keep that 1 over 5 outside. Okay, now if you divide each term by e to the negative 70, that means you are multiplying by e to the 70, right? 1 over e to the negative 70 is e to the 70 if you take it up. So if you multiply each element in this matrix by e to the 70, which is here e to the t, here e to the t, here negative 4 e to the 6t, here e to the 6t. Okay, so this is what we get. All right. Okay, so yeah, so this is phi inverse. Now you finally found phi inverse. Now next thing is multiply phi inverse by f. See, I am doing it very slowly. Phi inverse times f is 1 over 5. Phi is e to the t, negative 4 e to the 6t, e to the 6t times f is, I think, 6 e to the 2t, negative e to the 2t. I think I wrote it from the memory. Let's see, 6 e to the 2t, e to the negative. This is f, right? Yes. Okay. All right. So let's multiply in 1 over 5. Okay, so to multiply out, you multiply this row by this column. So e to the t, be very careful. This is one place you can get really wrong. E to the t times the first one is 6 e to the 3t plus, don't forget, e to the t times this one, it's not plus actually, minus here because of this minus, e to the t times e to the 3t. Okay, you get a vector, right? So now here negative 4 e to the 60 times this is negative 24 e to the 8t here minus e to the 8t. Okay, so this is what we get. Now combine this. 1 over 5. 6 minus 1 is 5 e to the 3t. We can do that because both of them are similar terms. Okay, they are both e to the 3t's. Here negative 4 minus 1 is negative 25 e to the 8t. Now you can see we have numbers divisible by 5. So phi inverse f is, if you divide each term by 5, this vector is e to the 3t. This vector is negative 5 e to the 8t. So this is phi inverse f. Okay, now still we didn't even do integration. Now let's do the integration because that is the next step. Okay, see, I am going piece by piece in this formula. So I am done with this part. Now let's finish the integration. So integrate e to the 3t, the vector negative 5 e to the 8t. Now you might ask, well, how do we integrate this? Integrate each row. Okay, so once you integrate e to the 3t, if you integrate e to the 3t divide by 3 plus c, yes, plus c1, but let's choose c1 to be 0. You can choose c here, arbitrary constant here. Here negative 5 e to the 8t over 8 plus c again 0. So this is the integral. So it was rather easy there, right? What we expected. Okay. Right, so this is the integral. Now what you want to do is, you found the integral, now multiply this by phi. Phi times this vector, right? E to the 3t over 3, negative 5 e to the 8t over 8. Right? So that is what the formula says. So we are done with the integration, now multiply by phi. So phi is, don't multiply by phi inverse, okay? So let's write it here. So phi is e to the negative t, negative e to the negative 6t, 4 e to the negative t, e to the negative 6t is phi, I believe. Yes, and what we found from the integral is e to the 3t over 3, negative 5 e to the 8t over 8. Sounds good. Okay, so let's multiply. Be careful. So here what we get is e to the negative t times this one is e to the 2t over 8, right? Because in negative t and 3t, you add them and then you get e to the 2t. Plus, here negative times negative plus, so that is why I add plus here. E to the negative 6t times e to the 8 is e to the 2t, okay? 5 over 8, that 5 over 8 is still there. Okay, so that is what we get from the multiplication from the first row. Now the second row, 4 e to the negative t times this is 4 over 3, e to the negative t, e to the 3t is e to the 2t. Okay, this one negative because this is positive and this is negative, negative 5 over 8, here e to the 2t, right? Okay, good. So let's see what we get. So here if we simplify, what do we get? So here 6 e to the 2t over 8. Okay, so that is what we get there. All right, and then from here what we get is did we do some kind of a mistake? This is not 8, this is 3, right? Yeah, I think I made a mistake there. So e to the negative t times e to the 3t over 3 is 3, right? Yes. Okay, so here what we get, it's not 6 times, it's to add these. Well, let's scratch it out, let's write. So here what we get is, let's see, excuse me for that. So what we get from here is, okay, so we have to find the common denominator. So common denominator of 3 at 8 is 24. So we multiply this fraction by 8 and this fraction by 3. So here 8 plus, so 23 e to the 2t over 8 times 3 is 24. That is what we get from there. So you can simplify, you can add fractions, right? So I will do that fast. 17 over 24 e to the 2t. So this is the particular solution. Okay, all right, so let's see how we write the general solution, which is easy from here. Xt is C1, the first 1 4 first eigenvector e to the negative t plus C2 negative 1 1 e to the negative 60 plus the particular solution 23 over 24 e to the 2t 17 over 24 e to the 2t. Okay, here it's just a fraction addition. Okay, here the common denominator is 24, here the common denominator is 24. So to create common denominator, you have to figure out the number that you have to multiply each these fractions and then add. Okay, all right, you can add them because both of them have e to the 2t terms, right? Okay, so this is the general solution. So that is how we use the variation of parameters methods. The most important thing to notice is we do it piece by piece of the solution. Okay, so particular solution formula is 5t phi inverse f integral with respect to t. So the steps are find phi inverse, multiplied by f, then get that vector, then integrate it, assume the arbitrary constants are 0, plus c's are 0, get that vector and then multiplied by phi. That is your particular solution. Okay, all right, thank you.